Hello students, welcome back. Let us resume our discussion in section 5. We went through some trigonometric functions. Okay, alright. Those have some horrendous computations there, but those are necessary. Now, let's do some tangency problems. Remember that? Basically, what we want is something like this. Y equals to m, sorry about that, y equals m slope, x minus x naught, plus y naught. That's what we want. X naught is typically given in the problem, and plug into whatever function, f of x, you're going to get y0. And then take the derivative and plug in, you're going to get the slope. Remember, that's where we are headed. The slope point equation. Okay, how about the first problem? Looks like this is a chain rule problem. So we have y equals the slope x minus of -1 plus y naught. But of course, nobody writes like this. Minus of -1. Everybody writes like plus 1. Yeah, x is given as -1. And then y0. Well, what is y0? It's not too bad. Plug in x equal to -1 here, then you're going to get, let's see, square root of -1 squared plus 1. Is that it? Yeah, I guess so. You're going to get square root of 2. So this one here is square root of 2. Now, if you get the slope, then you're through. The slope of the tangent line is a derivative evaluated at x equal to -1. So let's calculate the derivative. Y prime, what is it? Remember this, it's a chain rule problem. We already did it. 1/2 comes out, inside never changes, and then subtracting 1 from the power, and we have to multiply the derivative of the inside. So what do you get? X times 1 x squared plus 1 to the -1/2 power. And then this is, you see, 2 and 2 cancel out, so we just have x. And then 1/2 power, that goes to the denominator. Oops, sorry about that. And then a square root, x squared plus 1. Looks like we're going to get that expression there. So plugging in x equal to -1, you're going to get your m value. So that's -1 over square root of -1 squared. -1 over square root of 1. Square root of 2, excuse me. That's my slope. So the answer is, plug this one here. Oops. And then plug this one here. No need to take both like this. Not this one either. Okay. Solution, yep. Plug it in, square root of 2. Derivative computation and some simplification, and then plug in, we get, it should be negative. Sorry about the typo. And here, down here, I did it right. Let's see. Yes, here's a visualization, and yes, indeed, I have a tangent line. It's easy to see. By the way, I did this simplification so that I can plug in and do the computation through mental math. If you don't want to, then you can just appear Now plug in x equals to -1 and run your calculator. Can you do the same thing here? Take the derivative and plug in x equals to -1/3. That's going to be your slope. As for plugging x equals to -1/3, and then, looks like that's complicated enough too, so let's go ahead and do that. I was going to give you a calculation of y0 as your exercise, but excuse me, everything is your exercise here. Stop the playback and try on your own, but I wasn't going to do it at all, but looks like we'd better do this. Plugging in x equals to -1/3, so plugging in -1/3 here. So that's log of 1 plus 2, and then exponential of, let's see, 3 times -1/3, so -1 plus 1, so you have 0 power there. What's the 0 power? That's 1, so log of 1 plus 2, so that's log of 3. So why not is log of 3? What am I getting? We are getting this. Y equals to slope m, x 1/3 plus y naught, but that's log of 3. That's what we have so far. How about m? Take the derivative and then plug in -1/3. That's going to give you a slope. Remember that? Derivative function is a function. What you want is a slope, and that's the value of the derivative function, so you have to plug in. So y prime is, let's see, it's a log function, 1 over whatever that's inside. Oh, it's hard to read. Denominator and then another superscript. And then by chain rule, I have to multiply the derivative of the inside. But whatever derivative computation will be multiplied upstairs, so clever student will go right away and then do the derivative computation here. Okay, derivative of 1 is, okay, that's 0. And then 2 was there before. And exponential never changes, so it goes there. And then you have to multiply the derivative of the inside. Looks like that's 3, the derivative of 3x plus 1. Did I do this right? So 6 exponential of that divided by 1 plus 2 and the same exponential. That's a derivative function. But beware, what you want is the slope, not the derivative function. You don't get slope until you plug in. So the slope is plugging in x equals to -1/3 to this expression. It's hard to read, so let me expand the font again. 3 times -1/3, so -1, and a plus 1, so exponent here is 0. Same goes to the numerator. So 6 times e to the 0 power divided by 1 plus 2 e to the 0 power. E to the 0 power, of course, is 1, so you're going to get 6 over 1 plus 2. 6 over 3, that's going to be 2. So the slope is 2. That's what I'm getting through this computation. So plug in, you get y0. Derivative computation, and then plug in, you get the slope. So you have 2 plugins. Direct plug-in, y0. Derivative, and then plug in, you get the slope. You need those 2. Slope here, and y0 here. Here's my answer key. Point. derivative, slope. So the equation y equals to mx minus x naught plus y naught form, and the slope-intercept equation, oh come on, who cares about that? Let's not worry about that, just this one. And then the visualization. Does it look like a tangent line? Okay, it looks good. Enough time for one more, or maybe not, I don't know. How about this one here? Trigonometric function, just a straight ahead quotient rule. I'll leave that to you. This one looks interesting. Log of 1 plus 2 sine squared. It's a chain rule problem. Okay, alright. So y equals m x minus of negative pi over 4 plus y naught. That's what you're looking for, but of course nobody writes like this. Negative of another negative. Okay. There goes the equation of the tangent line in the slope point equation. X is negative pi over 4 given. Y 0, okay, let's find out. And then take the derivative and then plug in. You're going to get m value. Okay, right here, just plug in. Plug in negative pi over 4. Do you remember sine of pi over 4? Square root of 2 over 2. Negative pi over 4, so sine is negative, so negative square root of 2 over 2, but this is sine squared. That's what I'm getting. Square root of 2 over 2 is 2/4. So 1/2. Excuse me, square root of 2 over 2 squared, then we have 2/4. So 1/2 times 1, so that's 2. So that's log of 2 again. Check with your calculator if you want. Like this. So we have log of 2. How about the derivative? So 1 over whatever the inside. And then we have to multiply the derivative of the inside. But then again, this multiplication will just go to the numerator. So it's the same as doing the derivative computation to the numerator here. Let's expand the font. And the derivative computation here will regard, oh, a chain rule, another chain rule. We have sine squared function. Remember, outer function is not sine, it's a second power function. So derivative of 1 is 0, so you don't really have to do this. 2 is there before, and then the derivative of sine squared function, what is it? Outer function is second power, so 2 comes out as coefficient. Inside never changes. And we have to multiply the derivative of the inside. The derivative of sine is cosine. Are you with me here? I'm doing a bit quickly here, I'm sorry. Kind of pressed with time. So 4 sine of x cosine of x over 1 plus sine and then plug in pi over 2 and do your computation. Will that give me your m value? You're supposed to get -1 if you do it right. And then you end up with this equation. -1 and then like that in slope point equation. I guess that's it.